Oh, we're looking good. All right. Just kind of sitting in here. I'm sorry, guys. How do I keep on doing that? Yeah, so we have two equations. We have y equals -1 plus 3 sine of theta, and x equals 2 plus 4 cosine of theta. So in this example, again, we want to be able to eliminate the parameters. So again, we're going to use the same idea that we want to get rid of theta. So therefore, we're going to use the equation, or the Pythagorean identity, sine squared plus cosine squared equals 1. So to understand that, or at least to understand what we need to do, we need to solve for cosine of theta and sine of theta to replace inside of those. Agreed? And just remember that these represent the quantity squared, the sine of theta squared. This represents cosine of theta squared. So all I'm simply going to do is you're just going to add the 1 first. So y plus 1 equals 3 sine of theta. And then I will just divide by 3. So I have y plus 1 divided by 3 equals sine of theta. And then hopefully you guys can agree that here you can kind of do this in your head, x minus 2 divided by 4, right? Yes? OK, so that's what sine of theta and cosine of theta equal. Let's just apply them in for sine and cosine. So I have y plus 1 quantity squared. Oops, I'm sorry. Plus x minus 2 over 4 Now remember, what do you do when you have a fraction raised to a power? No? You know? Oh. So what you're going to do is you're going to take the numerator squared as well as the denominator squared. Now you could expand this, but hopefully you guys recognize the x minus h quantity squared, y minus k quantity squared is the form that we want, right? We don't need to expand this out. So I'm just going to leave this as y plus 1 quantity squared over 9 plus x minus 2 quantity squared over 4 equals 1. And obviously, you could rearrange those if you want to. Now, in this case, though, I recognize we have a little of an issue. Because, again, yes? Did I multiply? 4's 16. Thank you. Thank you. Did I just keep it as 4? Yeah. Okay. All right. So now, is this a circle? No? You want to check in a circle? Well, what we can do then, again, let's still just try to write this into this other form and kind of make sense. So if I want to get rid of the 9 and the 16, what should I multiply that by? Does anybody have an idea? Yeah? Yeah, which is 144. So if you multiply by 144, 9 goes into 144 16 times. Y plus 1 quantity squared. And 16 goes in 144 9 times. OK, so this is what we call our general form. Or actually, well, it's not really our general form. This is our standard form, but at least with no denominators. But the important thing I want you to understand, though, compare this to a circle. Does this look like it's a circle? Does it look like it's evenly, the x and the y's are evenly distributed here? No. Right? And this is actually going to be distorted. And we're going to learn about that next chapter. But you can see that this is actually not a perfect circle because the coefficients of x and y are not the same. So therefore, this is going to turn into an ellipse. All right? And we'll see this how to do that. So I forgot to show you guys how to do that on your calculator. So let's go